Hello class, and welcome to lesson 6.5, creating equations from graphs. Just remember that last day we gave an equation. We took a look at what A, D, C, and K were, and then we were able to draw a graph. Now we're going to work backwards. We're going to give you the graph. We're going to have to decide what the A, K, D, and C are, and then give the equation. So we're working a little bit backwards, but before we do that, let's just tie into some things we should remember from last class, the last couple classes, some key points that are going to help us from the graph. So just remember, guys, we know the period equals 360 degrees divided by the absolute value of K. Just remember, today we're going to be given a graph, so you're going to easily be able to see where the period is, so we're going to be able to find the K value. So the absolute value of K equals 360 degrees divided by the period. So that's a new one that we're going to be using today. All right. Hopefully you remember, ladies and gentlemen, the amplitude has to deal with equaling the absolute value of A. The axis is based on the equation y equals c. And again, you got a graph. It's going to be easy to find the axis in most cases. And D is our starting point. So remember, D is where we start to draw our box from. So I'm just going to leave it half open because that's where we start. Our minimum, ladies and gentlemen, is related to two things. It's related to the axis, which is c. And then you've got to subtract your amplitude to get your minimum. But for your max, it equals c, and you add your amplitude. And again, ladies and gentlemen, the range is based on your minimum to your maximum. So y belongs to a set of real numbers such that your minimum, which is c minus absolute value of A, has to be less than or equal to y, which has to be less than or equal to your maximum, which is c plus absolute value of A. So those are pieces of information that are going to be helpful for us to determine the equation from a graph. All right. Just remember, ladies and gentlemen, there are two base functions. There's the sine x curve and the cos x curve, or you could argue, say, the sine theta curve and the cosine theta curve. Those are your parent functions. So in the question, when it says write two equations for each function, that's the functions, the graph given below. One is going to be the cosine curve and one is going to be the sine curve. So even in your homework, when it asks for two equations, make sure one is based from cosine curve and one is based from the sine curve. All right, so let's take a look at our first equation, our first function, and it's in graph form. And I'm going to take a look, and you should be able to, from a graph, decide what looks easier. The cosine curve or the sine curve to start with. And what I'm going to notice, folks, is when I look at my start here, and look at this value here, I'm at my maximum and I am starting with my maximum. And which base curve, base function starts with that? And that is your cosine. So let's start with cosine. If you have two different colors, that's going to be helpful today. I'm going to use, for the first one, I'll use green. Okay? So for cosine, ladies and gentlemen, remember, it starts at its max and it ends at its max. Okay? So these are my max. So remember, guys, when you start at one max and you go to your next max, that creates what we call our box, which shows one cycle. Okay, so let's draw that in. Okay, so one cycle is helpful for us to define some information. The first thing we can find, ladies and gentlemen, is the period. How long does it take to complete one cycle of this cosine curve? It takes a period of 10. So if we know that a period for this box equals 10, that's the time it takes to complete one cycle. It could be 10 degrees. Okay. Remember, we can sub in K equals 360 degrees divided by the period. Okay, so sub that in, so it's 360 degrees divided by our period, which is 10 degrees. So that tells us that K equals 36. All right. Once we know our maximum, and we should note that our minimum is down here, okay, halfway between is our axis. Okay, so halfway between our axis, and you're not sure, just remember to find your axis. That equals your max plus your min divided by 2. If you can see on the graph right away, go ahead. Our maximum here, ladies and gentlemen, is, my fault, it's 3. Can't see because I wrote over it. Plus my minimum here, ladies and gentlemen, which is -1. So you're plus adding a negative divided by 2. So you're going to get y equals 1. Okay? And if y equals 1, remember the axis is y equals c. So therefore, we know c equals 1. Okay? So axis will help us to get the c value. The period will help us to get the k value. So what other two letters do we still need? D and A. Okay? A is the amplitude. And before I do my amplitude, I'm just going to draw in my axis on my graph because it's going to make things a little easier. Okay? So this is my axis. Okay? And what I need to do is figure out my amplitude. My amplitude, remember guys, is the distance from your axis to your maximum. So if I'm at 1 and I end up at 3, my amplitude here, guys, equals 2. What does that tell us? Therefore, A has to equal 2. And D is the starting value, ladies and gentlemen. So D, just going to leave this over here because I forgot I've got to do my other equation, so I just got to leave room. Okay, so D, ladies and gentlemen, is where we start. Did we have to shift left or right of the x equals 0 to start at our max? And the answer is no, because we started right at our axis. So that tells us D equals 0, and that was our starting value, right? So now, ladies and gentlemen, notice we have A, D, C, and K. So we can sub all of those into our formula. So using the transformation formula that's given above, we're going to say y equals A, which is 2, cos, because this is the base that we're using, k is 36, so 36x, there's no d, so it's just 36x, okay, and plus c, which is 1. So there's your first equation there, guys, and that is the cosine one. Now we're going to do the sine one. And some things are the same with the sine curve, and some things change. Okay? So let's take a look at the sine curve. So sine always starts at its axis, and it goes up to its max, back to its axis, down to its min, and up to its axis. So looking at my graph, ladies and gentlemen, right here I notice is where I would start my sine if I wanted to start with positive values because it shoots up or down. Or you could say, hey, Mizar, this one's actually closer, so I like doing this one better. So in this case, ladies and gentlemen, you could have two answers here, okay, depending on where you started. So let's just start here. And if I drop my box down right there, I draw my box, it's going to be like this. Okay, so I've got my box, which shows me one cycle. Okay, and from that, ladies and gentlemen, looking at the amplitude, what is the amplitude? It is still the same as the cosine surf. So much of this work has been done. Amplitude equals 2. You just have to look to see if it's opening up versus opening down, because then sometimes that could be flipped. Okay, what else do we know? Is the period the same? Yes, it is. It still takes the same amount of time. So what does that tell us? If the period's the same, we also know that K still equals 36. All right, the equation of axis is at the same point, so we know that C equals 1. But what changes is D. So we've got to worry about our D, which is our start value. So all we have to do is look on our graph and say, hey, instead of starting here at the origin, I've started 1, 2.5 to the left. So what does that tell me? That D equals negative 2.5. Or, ladies and gentlemen, if you had started this being your home or your start value and had ended here, it would also, you would use D being 7.5. Okay? Doesn't matter because it would still graph out to be the same because it's already completed one period. So subbing this in, ladies and gentlemen, again, you're using the sine curve, so it's going to be y equals a, which is 2, times the sine of k, which is 36 degrees. And remember, we've got a shift, so it's going to be bracket x, and it's negative. So when you subtract a negative, it becomes a positive 2.5 in there. And then we've got to add 1 to it. Okay, so there's the equation for the sine base function, and here's the one for the cosine. So those are your two equations to explain this function. All right, let's try another one. Getting a little bit more harder, but we can still do this. Sorry, a little harder, not a little more harder. Okay, doesn't make sense. Anyway, B, here we go. Taking a look at this, we can decide if we want to start with cosine or sine. I look where I'm at, and I'm at my maximum where? I'm at my maximum at the start there. So that would means I'm going to deal with cosine first. I'm just going to write cosine in this color. All right. So cosine means I go from max to my max. That helps me to draw in my box of my one cycle. Okay, looking at that box, ladies and gentlemen, how long did it take me to complete one cycle? Looking at that, you'll see that's a period of 180 degrees. So period equals 180 degrees. From that, we can find k, because k equals 360 degrees, divided by the period, which is 180 degrees. So in this case, k equals 2. All right. If your max is at the axis, ladies and gentlemen, and you're talking about a k reflection, wondering if it's going to be negative or not, it's going to be exactly the same. The only time you're not going to do that is if it's shifted over, and you'll probably just pick a different point to start with. Okay. So in this case, k equals 2. Okay. We also may want to notice that, ladies and gentlemen, we know our maximum. We know our minimum is down here. So our minimum is down here at -2. Okay, so hopefully you can see that our axis, ladies and gentlemen, is right here in the middle. So what does the axis tells us? It tells us that y equals 2. What letter represents the axis when we do our transformations? You learned that last class. So therefore, c equals 2. Just remember, by definition of the equation of the axis, it's y equals c. Okay? Which is your max plus your min divided by 2. It's how much you've shifted the whole wave either up or down. Okay? It's your vertical translation. Okay? So far we've got k. So far we've got c. Now we need to take a look at our starting point. What's our starting point? Actually, we're starting at our axis. So what does that tell us? D equals 0, which is our start, right? Okay, so we're starting at when x equals 0, so d equals 0. And the last thing we need to do is figure out our amplitude. So our amplitude, ladies and gentlemen, is the distance from your axes to your max, or max subtract axes if you want. And you're going to realize that the amplitude, in this case, equals 4. What does that tell us? Therefore, a equals 4. Okay, this we got to keep an eye on. Sometimes this can be negative if we're starting at our minimum and working to our maximum. But notice this is the regular curve, so it hasn't been reflected by the axis. Okay. So now that we have all 4 components, A, D, K, and C, we can sub them in. So therefore, we have y equals a, which is 4, times the cos of k, which is 2x, okay, plus my c, which is 2. Usually the one you start with is going to be the easier one, okay, in terms of usually won't have a d value in terms of writing that out. Let's take a look at our second one, ladies and gentlemen, sine. Now, sine has many approaches how you would take a look at this. Depends on how you want to look. Looking at the information given in our graph, you could do one of two things. I could A, say, hey, here's where I'm first at my axis, but what I need to realize is that it's negative. So I'm going to write down y equals negative sine x. So I know that A is automatically negative because it's going to be reflecting. What does that mean? Normally it goes up, right? From your axis goes to its maximum, but here it goes axis to its minimum. That's what we're going to do today. Or you could take a look at another example where I'll show you the equation in a different color where you actually start it in its positive sense. And you then complete your box this way. The reason why I'm using the blue one, ladies and gentlemen, is because I can actually see one complete cycle, which is from here to here. So if I draw in my little box here, guys, and you can use a dotted line or a solid line, doesn't matter as long as you can still see what you're doing. Okay, so in this case, ladies and gentlemen, for the sine, I'm going to automatically put in y equals negative sine x. So I know automatically the negative means that instead of opening to its maximum, it's opening down to its minimum. Okay, what does that tell me, guys? That tells me that A is negative. So we know the amplitude's the same. We know it's still 4, but we're going to call it negative 4 because in terms of A. So A equals negative 4 because it's reflected by the x-axis. Okay, we know the equation of the axis is the same, so we know C equals 2. All right. We also know that the period, the length of time it takes is still the same. It's still 180 degrees. So we know that K is, when you put it in the formula, K equals 2. But what we have to worry about is our start value. So how far along did we start? It looks like it's 45 degrees. So we're going to write down D equals 45 degrees. Okay. And then we sub that into our formula. So in this case, y equals A, which is negative 4 this time. Okay, and that's going to be sine times K, which is 2, and it's going to be x minus 45 degrees, and then plus 2. The other option, ladies and gentlemen, and again, there's more than one solution depending on how you looked at it. The other option is if you started here. Okay. So if you decided to start here, it's perfectly correct answer as well. Okay, you just wouldn't be able to get one complete box in your diagram. That's okay. You already know the period from before. So if you had chosen this method for sine, okay, notice it's positive, so it's going to be y equals sine x in this case. So A is going to equal 4. Okay, the axis of symmetry, equation of axis stays the same. The period stays the same. But what D will be is we have a shift of how many degrees? 135 degrees. So another example of this solution, ladies and gentlemen, would be y equals 4 sine 2 times x minus 135 degrees plus 2. Okay, so I just showed you a second example, ladies and gentlemen, and we'll move on to graph C. So taking a look at graph C, again, I see in graph C that there's multiple cycles here. So you could have multiple answers depending on where you started from. But I'm always going to start with the most basic expression. So looking at where I start, this starts not at my maximum, but at my axis. So that tells me that we're going to start with sine first. And because it's going positive, I know it's going to be y equals sine x. Okay? And because it starts there, ladies and gentlemen, that will tell us that this is your equation of axis. Okay? I will also, at this point, draw in my box. Time it takes to complete one cycle. And we've got a lot of information there. So first of all, what do we know about that? That tells us that C equals 8. Okay. Once we've boxed in our one cycle, we'll see that how long does it take for the period. You're going to figure out that period equals 4. Sub that in. K equals 360 degrees divided by 4 degrees. So K in this case equals 90. Okay. All right. We'll take a look at our amplitude, ladies and gentlemen. To find our amplitude, we started at 8 and we went to 11. So our amplitude equals 3. So that tells us, ladies and gentlemen, therefore, A equals 3. And the last thing we need to take a look at is our starting point. Okay? Our starting point is D. Are we starting where x equals 0 at our axes? Absolutely. So D equals 0 because there's no shift. We just start at axis when x equals 0. All right. We got our 4 things, guys. That's all we need to sub in. So what we're going to write down here is y equals 3 sine of 90x plus 8. And this time, ladies and gentlemen, it was easier to do the sine first, just depending on what function you're given. Okay, now we'll take a look at the second one. Okay, if we had, if we wanted to take a look at doing our cosine, ladies and gentlemen, we would start here at our max, the first max I see, and we would end up at our second max. So if I draw this box in, okay, started this box, we would take a look at the amplitude being the same. So for cosine, we notice it's going from max to max, so we know it's y equals cos x. It's not going from min to min. That would make it negative cos x, right? Okay, what else do we know? We know the amplitude is still 3, so A equals 3. We know the axis is the same, so that's C equals 8. We also know the period is still the same, so the K value remains constant at 90. What we need to figure out is D. How far over has it shifted? Okay, and if you take a look, D equals 1. Okay, now you've got your 4 pieces of information, sub it in. So y equals 3 times cos of 90 degrees times, sorry, of 90, my fault, subtract 1 minus, or x minus 1, which would be degree if we're talking about sinusoidals, plus 8. All right, any questions there, folks? All right. Again, ladies and gentlemen, I just want, before I go on, you could have multiple solutions here. You could have, for the cosine, you could have D equaling 1, or in this case, you could have D equaling 5 and do the box this way, or you could have D equaling 9, because it's every time the period's been repeated by 4, right? So you just change it. Likewise, if we take a look at the sine, if we started at 0, did our box, you could also start here at 4 and do your box. You could also start here at 8 and do your box. So only thing that's shifted is D, and D is shifted the same amount as your period. Okay? Depends on where you draw your box. Okay? That's why it's important on your test, ladies and gentlemen, to always show me your box to fit the equation that you're giving me. All right. Now, this last one, ladies and gentlemen, it says to give an equation to model the data below. I always think that visually it's better to sketch this. So on a quick sheet of paper, just quickly sketch this. We know we've got 30, 60, 90, 120, 150, and 180. We know we've got a scale going of 1, 2, and 3, 4. Okay. So what do we know? Starts at x is 0 and it's at 3. Then we go 30 degrees and we're at 2. And then we go 60 degrees and we're down at 1. And then 90 degrees, we're at 2. At 120 degrees, we're back up at 3. 50 degrees, 150, we're down back at 2, and 180, we're back at 1. So we take a look at drawing your smooth curve through here. It gives you an idea of what we're looking at. Okay? So it says an equation. Doesn't mean that we need to have both. We need to take a look at where we're going to start. and looking at the starting value to keep to keep D equal to 0, we're starting at a max, right? So this is your starting point here. Okay, so we're starting at max. So at our max value. Therefore, that tells us we're going to use the cosine. Okay? All right. We're not at the origin, because if we started at 0, 0, that's when you would use the sine x curve. All right, so that's our starting value. Next thing we need to do is try to figure out our equation of axis. So looking on the little graph that I just drew, ladies and gentlemen, hopefully you realize that your equation of axis is 2. So we know C equals 2. Okay. Now to do your amplitude, you can take a look at your graph and say, hey, what's my distance here or here? Or taking a look at your first differences, ladies and gentlemen. 1 subtract 2 is -1. 2 subtract 3 is -1. 3 subtract 1 is 1. 2 subtract 1 is 1. 1 subtract 2 is -1 and -1. So you notice in your first differences, ladies and gentlemen, if you take a look at the absolute value of that, it would be your amplitude. So amplitude equals 1, because A equals 1, because it's the absolute value of A, right? All right. So so far we have A equals 1, right? We have C equals 2. What would D equal, guys, if we're starting at our maximum at when x equals 0? That tells us that D equals 0, because we're going to start there at our max. The last thing we have to do is figure out K. In order to figure out K, we have to say, hey, at what time do we get back to the same value of 3? Because these, you go to max to your max. And so what does this tell us here? This tells us that our period is what? 120 degrees. Sub that in. K equals 360 degrees. Subtract 120 degrees. So it tells us that K equals 3. Now we have all 4 pieces of the puzzle. We can now sub it into the equation. So y equals cos of 3x plus 2. I would always go with the easiest expression. I know some of you can say, hey, Ms. R, can I model this with a sine x and start it either here, or you can even do a negative sine x and start it here. Absolutely, that's correct. However, I would always do the easiest one for you. If you can start with d equaling 0, your expression is much easier, and there's less room for error. All right, there's a good go at, ladies and gentlemen, at having a function and coming up with the equation. Most of the examples are in a graph, but that last example was a table of values. Taking a look at your homework here, guys, page 391, numbers 3 to 6 and 12. Have a great day, and come and see me as always for some extra help if needed. Have a great day.